Here we're looking at a diagram of a coil-on plug. This is a two-wire system, meaning that the coil only has two wires coming from the connector. Your coil is going to have constant battery power, and then your ground side of your coil is going to actually go through your PCM, and there's a transistor in the PCM that controls when the ground side is activated and when it's deactivated. So basically when it's activated, it's going to build up a magnetic field in the coil, and then the computer is going to tell it to deactivate the ground leg, and that's going to cause a collapse in the magnetic field, which causes a voltage spike. This voltage spike is going to go through the secondary coils and then get sent to the spark plug. So here we're looking at a typical three-wire coil-on plug coil system. Same concept here, except not only do we have a transistor in the PCM, but now we have a transistor that's internal on the coil. So basically you're still going to have constant battery power coming to your coil. Your ground circuit is still going to be controlled by this transistor. The only thing is this transistor has a signal wire, and basically your PCM still sends a signal to this transistor whether to allow the ground to complete the circuit or not complete the circuit. So basically it works the same way as a two-wire, except you have a signal wire from the PCM controlling a transistor that is internal to the coil. So this here is a spark plug. This is probably the most important part of your ignition system. This is what sends the spark to start the combustion in your cylinder. So here we have the threads, and then we have the arc that comes through here, and then your coil goes on top. Your spark plug should usually operate between 746 degrees Fahrenheit and 1460 degrees Fahrenheit. So here we have a spark plug gapper, which basically just fits in between the gap that your spark arcs across, and as you can see here, it is at 0.050. So in each spark plug you have the ceramic that comes down, and depending on how far it comes down into the threads is going to depend whether your spark plug runs hotter or colder. So as you can see here, we have the ceramic that comes down about halfway the threads, and that's going to run colder, and then you have this ceramic which is not even a quarter of the way down the threads, and that's going to run hotter. Here we're looking at a wiring schematic of the ignition system on a Sequoia. So up here is our igniters and ignition coils, and as you can see, I have highlighted in pink the power path from where it comes from up here through the fuse and gives the coils power. And then your ground path is going to be your green, which is going to be controlled by your ECM over here. This is a four-wire system, so the orange wire is going to be your feedback wire, which is going to also get sent over into your ECM. One test you can do to see if you are getting signal at your coil is go ahead and back pin the signal wire of your coil harness, and then basically we have a lab scope hooked up here. It's not reading anything at the moment because we have to start the car, but once we start the car we should be able to see the signal that the coil is getting. So with the car started, you can see here, this is the signal that our coil is getting in order to cause a spark. Another way to make sure that your coil is getting sufficient voltage in order to create a spark is to use this here. This here is a spark tester. So this just plugs right into your coil. This will clip onto a ground, and then through here is where it will spark. If we wanted to check to make sure that we were getting power and ground to our coil, one test that we could do would be to grab a digital multimeter, hook your red lead to the positive where your power is coming from, and then to chassis ground, and as long as you're getting 12 volts at the coil with the car running, then that's performing as it should. To do a ground test, basically you would disconnect the coil from the harness, and then you would hook your digital multimeter up to the ground of the coil and then to chassis ground, and make sure that that's sufficient.